think we should be live. Yes. Looks good. So let's see. I think we should be live. Yes. Looks good. So let's see. Okay. Hello, welcome. I'm not sure who's online right now, but yeah, it's the first stream. It's more of a pilot, trying to get somewhere. um, EC terminal. We will need this one for sure. I already created something to work a bit on, and yeah, we'll see. This will be a really explanatory stream. And yeah, I really hope we get to a point where yeah, everybody learns a bit, where I can also get some content afterwards to put it in the video. So yeah, thank you very much. Today's topic, as it says in the event, is yeah, just the first step of a series. I hope to test out what local AI can do for us, and where we start or where we stay at the moment is basically we have several local LLMs which we can fairly easy run. I will show a bit about that too. And I thought, like, I have several issues with AI and things like Copilot, for example, at the moment. But Microsoft is like, I think they are too like one-sided. I think a good example of a good implementation would be the Copilot meeting capabilities, where yeah, like there is like a fair amount of automation going on, and yeah, like reducing the task of protocols a lot, and that's I think a good implementation. Everything else is a little bit too passive, and my thing, and it's also something I want to have to evaluate the stuff, is how can we get to a point where yeah, we can have LMs not only like give a question answer from a retrieval, but also do stuff for us. And we have different challenges here. Maybe we write something down. Challenges building AI agents, because that's basically what this is all about. So we want to have some way of shape or form to build AI agents. And I, for myself, would love to have at some point when we have some functions ready, to build kind of a benchmark where we can test new incoming LLMs and their feasibility and their ability to fulfill tasks. One thing that's basically everywhere is, and that's basically also hindering LLMs working better, is the whole stuff of complexity. So we basically have the point right now where we have models that are small, we have models that are like mid-size, and then we have like really big models like GPT-4, which we are not even close to be able to run on our systems, and they're also closed source, so or closed weights for that matter. And the thing is, the bigger the model, the more it seems to be able to handle complexity and complex tasks. The smaller it gets, the less complex the tasks have to be. So if we want to reach like a high level of complexity, we will have to just say, okay, we need a bigger model. Or we go another way and try to reduce the complexity. So basically saying, hey, what is this whole thing about complexity anyway? Why can't we just go ahead and um, reduce the complexity into small tasks? Which will lead to us saving, basically saving inference time, which basically saves cost. We will save energy, something that's hardly overlooked, and we will increase our ability to run stuff ourselves. Yeah. And also, like, one, I think, in between solution, which sits like somewhere around here, will be like mix different models. So if you have a task, you can reduce the complexity by splitting it up, but then you go ahead and you have one task which just needs more intelligence, you can say, or more capability of the model. Then for this one task, you try to just go ahead, use a bigger model, and and the next step you keep going. One good example I could give is also I think 2 weeks ago I reworked the pipeline of our timeless AI solution, and still not completely released now, but I'll give you an update soon, promise. But yeah, what I've done is I reduced the overall complexity of the pipeline by doing more work beforehand with a bigger model, it's just one-time work which I used to initialize stuff. So after initializing this, I was able to reduce the complexity of the chat itself and the retrieval and the whole pipeline so much that I could go to a much smaller model. This saved time. This saved costs. I'm talking about like reducing cost by 50 times or something, or 1/50th of what it has been before. And yeah, that's basically where I thought, okay, how far could we go? Because optimizing stuff sometimes it's also fun, and I'm pretty sure that a lot of you, could use a lot of optimization to, get better results, and getting overall better, better performance and more. It makes you less reliant on one specific model, which is like the big model. And my co-host of our podcast, the AI Boardroom, I will plug it here and there. But yeah, the overall complexity, like using a bigger model for small tasks, is like taking up like a big cruise ship just to go over the river instead of a small agile boat. That's a really good analogy because it costs a lot. Okay, so that's more of why I think this is important, and complexity, and reducing complexity, splitting stuff up into different tasks, leads to more complex, or like more complex solutions. Not necessarily complicated, but complex. Like we have different parts moving and working together. So if I try to solve stuff, I usually have some core principles. Like one principle would be is what I want to automate something that I have my keyboard off. Something that I want to that needs language understanding. So that's basically what I ask myself every time when I get into any AI development. It's like, is language the key, and understanding language the key to solving the tasks? For example, now we can jump to our email. So this is the whole loading email, check for unsubscribe, but yeah, this is the LLM part. So execute LLM classifier is something that I like tried to do with the local LLM in today's video. So we will load the emails. We will check the emails for some low-hanging fruits. For example, does it contain an unsubscribe button? Then basically delete the email. Or if it does not, then we execute the LLM. So that way, like, we save the step, and if we go beyond that, we'll see what the LLM can do for us. Next would be if we execute the LLM classifier. It goes ahead, it reads the email text, and then it labels the email text in the first place. So if it's a newsletter, we might check if it's older than a week, which would be like classical programming. And if so, we delete the email, go to the next one. If we do not, if we do not have a newsletter, we check the email if there is something to do. Like, do we have an attachment? Do we have? Is it maybe an invoice we have to pay? Is it something where any kind of to-do is connected to? So this is only possible if our program understands what the email actually says. So we go ahead and try to understand the language and derive from unstructured data, which will be the text, structured data, which would be a task. We would create the to-do. We would make the email as read, of course, not unread. And then we're basically done with that email, or we're load the next email. So that's a bit wrong in the arrows here. So that's what I mean. Like, is what I want to automate something that needs language understanding, and basically, can we use unstructured language to then go ahead and make something structured out of it, which would be basically my second principle for evaluating if something can be automated with AI. Do I have unstructured data that could be transformed into structured output? Structured output can be something like to-dos, which we derive, but it can also be something like unstructured text, and I generate a JSON, which I work with. So JSON format, for example, is necessary in most, I think even all of my stuff. So I really try to get the JSON back for everything I do with AI, because I then feed it back into my regular code and work with it. And JSON, is a format that most AIs like. I think I know JSON. There's even a JSON mode on OpenAI's models, which I can activate. There are specialized open source models that are trained to basically do really well in outputting JSON format. So that's yeah, definitely something. Most LLMs can do this by themselves. So let's try quickly something. Um, let's try Ollama, and we start phi3. I explain what Ollama is in a second. Okay, then we take Llama. Dolphin Llama 3 is like a fine-tuned version of the Llama 3 8 billion model. And if I say give me a JSON with some dummy data for dummy data in form of a contact list with the properties name, age, and gender. So, and you see what it outputs is basically straight JSON. I didn't define that I need the contact property. That's something he just like assumed now. But you can give like proper instructions to an LLM, and it will output JSON format. By the way, this is run locally on my notebook, which is right now also streaming and doing everything else. So you see, like local LLM is really, really real and works pretty fast. And with Llama 3, it also got a hell of a lot more capable. So Llama 3 has a performance that goes, I think, even beyond GPT 3.5 Turbo. So yeah, it's just really cool, and it inspired me to even start doing this here. Okay, so back to this. So like I said, I had basically an unstructured request, and it gave me back structured data, and that's like more of a core concept. So that's basically the two things I'll try often, also in the podcast. I oftentimes mention it, like, is what I want to automate, does it need language understanding, and do I have unstructured data that I can transform into structured data and generate value by doing it. So like that must be like basically the overall rule. Does it create value? So if you have these core principles in mind while evaluating if you want to introduce AI into a process, into a business model whatsoever, this is definitely something you could have and could keep in mind. That said, I would say let's start building, right? So I have just to check where my chat is and if something's happening. Don't know if it's okay. This is active and cool. Dashboard. Okay. Interesting. Good. For the next like for the upcoming streams, I'd love to have some music, but with all the copyright claims and everything, it's not as easy to keep care of that stuff. So yeah, like I said, it's a pilot. It's a first try, and I'm actually it's a pilot. Try. Actually, I'm only on I'm stereo on one signal. That's not good. Let me change this. It's mono. Yeah. So now you should have me on both channels. Sorry for that. Um, okay, cool. Let's see. Theory out of the way. I want to build something. I would love to keep this episode or like the stream somewhere around the 1.5 hour mark. Let's see how far we can get. I would love to have prepared the email loading, but to be honest, I wasn't. I hadn't had proper timing for that. What I want to do, I would love to open Visual Studio Code. Maybe we make another window for that. So let's open Visual Studio Code. I want to open a new directory. Oh, wait, maybe we first of all cd development stream, and I have something I like to do, and that is not use Python for AI development. I do a lot of things in JavaScript, sometimes even like just plain using the APIs provided by the systems. At the moment, we still rely on LangChain for our systems. I also looking forward in the future episode to try to build with some AI agent frameworks. But so I would do following: Bonix, create next app. So email assistant. By the way, all the code we produce here will be available on GitHub. So that's that. Actually, do I want to use TypeScript? Yeah, let's do it. No. Yes. No. So what we do now is we create a Next.js project. Next.js is more or less a backend technology integrating React, which I use for my frontend application. It's meant to be serverless at some point. It's also how I developed the whole application already. It kind of works pretty well. It falls apart if you have really long long outputs. So video, okay. Yeah. So let's cd into email assistant, and if we now say bundev, we should already be starting up. And can open it here. Development, stream, email assistance. Okay, yes, this is our code. I personally love to use the terminal in VS Code. I know that's not everyone's favorite, but I really like to do it like this. So if we say bundev, we are able to start the application, copy that, throw it in here, and yes, we have a running application. Hey, so having done that, I would love to just throw out everything that's not used. And we see it's an empty page. Keep the background, and then we say H1, this is our new email assistant. So, and you see it's updated directly. So what do we need to do? So first of all, we need to load some emails. So what I would love to do is use the Graph API for that, but maybe for the time being, we just try to mock some data. Cons email mock data. Send a subject as a test email. Yeah, let's make it an array. And create a bit more. So if I use Copilot, mock data for 10 emails containing news, letters, invoices, and personal emails. Let's keep it like that. Let's see what we get. No, I don't want this. I think the better way would be to use Copilot Chat. So if you don't know, this is GitHub Copilot. I have it activated. It's not the most loved tool in the world. I kind of like it because it auto-completes so much code for me. And also knows a lot of the code base. So yeah, I really like it. So, and I also give it to every developer who's working with me. Just so, yeah, that I know he's most effective he can be. I'm not sure why it gives me back the type, but yeah, that's something I'd love to do with Copilot, just to go ahead and let it generate some mock data. Yeah, and as easy as that, we have some samples. These are pretty simple samples, but we will at some point load the real emails. So yeah, if I want to go ahead and render these out, I can just say, hey, mock emails map. So I don't know where it gets this from. So we map it out and we'll see, oh, yeah, we have a bit of formatting issue, but here are our emails. Background gray, that's causing issues. Okay. Maybe we should do BG to at least give some, yeah, that looks good. Let me just quickly rearrange this. Okay. So what have we done? So we created some mock emails. We rendered them out, and now we have our emails. Maybe we just also put the email body is already in there. Okay, never mind. Also, if you don't know Tailwind yet, it's basically giving you some pseudo CSS elements. No, not pseudo is the wrong word, but like prepared CSS classes. So that's the right one. Which basically give you the option to quickly, for example, change backgrounds with autocomplete. It's kind of nice. And also the color palettes that are in there are basically like properly prepared and made. So let's add some padding. P4 and some margin top. And let's round. So our round is a bit small. So now we have a rounded body. And yeah, I'm not sure. I think we have to have more complex bodies for this whole thing to work out, but that's that. Now let's talk about how we actually run stuff locally. So we have something that is called Ollama. You can just spin up basically any LLM that's in the Ollama library. How do you find Ollama? So there is an ollama.ai website where, yeah, basically, I think even 5.3 was directly put by Microsoft into Ollama. So that's how much attention it gets. For me, it's like a really cool way to just install local LM. If you're on a Mac, it's like as easy as just downloading and installing it. If you're on Windows, it's still in preview. But what you can do on Windows is use the WSL, like Windows Subsystem for Linux, which is available on every Windows installation. I think you're a bit out of luck if you're on a Mac with ARM processor or like Apple Silicon and try to do virtualization. I think that's still not possible. But besides that, yeah, use Linux in your Windows terminal and then install it there. It's the better experience anyway. And this Ollama site also has a library. And here you see all the LLMs that are available in Ollama. And for example, if I want to add a new LLM, let's try something small. I think we had the Arctic embedding model somewhere here. Yeah. So there's Snowflake embed, and then you basically go ahead, say Ollama pull, and in the terminal you can just do it like this, and then it starts downloading the model. It's like yeah, somewhere around 700 megabytes. Like it downloads mostly one bigger file and some smaller files. So and after that, it's basically done, and you can use it. And you can use it just by saying Ollama run Snowflake Arctic embed. Yeah, if I let's do just this run. Okay, it's an embedding model, it does not support chat, so never mind. So the Ollama run in the terminal tries to run a chat experience. The embedding models are not chat experience. Why is Ollama special? First of all, you can install basically a whole bunch of LLMs. These are all the ones I have on my machine right now. The biggest one being Command R, FP16, which I will not start right now with streaming and everything, because I learned that every FP16 model really, like, it's a non-quantized version, and it's really getting your system to work. It works, and it's like it has some tokens per second, but it's nothing you can really like use. If you want to use this in production, like get the normal latest version, which most of the times is quantized in 4-bit. You can see this. You can see this here. Quantization F16 right now for the one we pulled, but if we, for example, would take Llama 3, and then we have here the 8 billion model, and you see it's like the quantization is 4-bit. For all of you that don't know quantization, quantization means basically you reduce the bit size for your weights. So if it says FP16, it's basically like the standard weight is like how much bit has the one number, like one weight. And by reducing it to 4-bit, you lose a bit. You lose a bit of your performance, but you gain a whole lot of like inference performance, and it makes stuff runnable. So if you just have a look at it, like you have the 70 billion instruct Llama 3 model, which is like 40 gigabytes if you have a 4-bit version. And there are also 5-bit, which is 50 gigabytes, 6-bit, which is 58 gigabytes. And if you take the whole FP16 model, it will be around 141 gigabytes, which is like basically the unmodified original version. And I think you have to test how far you can go with what you have. I would, for the time being, suggest use the normal model, which is most of the time the 4-bit model, and just run it, see how far you come, and like if you feel that your hallucinations or your behavior is kind of weird, you just pull another model and just run it. If you look at the system and the CPU, like you see, I have now data in the caches because like I have a lot of RAM. My system just saves the models that I run previously in the chat. But Ollama like loads models on request, and this in and of itself takes a bit of time. After that, it's mostly cached, and you can run it a little quicker. So that's how you can have basically all the models installed and then use the models you need to when you need to. But again, why is Ollama so special? Ollama is not only something to execute. Ollama is actually a server. So I think you can't see it here. But Ollama is running in the background, and it's a server. And I can reach that server by saying localhost, and I think it's I forgot the server. Default port 11434. So, and you see Ollama running. So Ollama is running on my PC, and I can, like I would use the API URL of any API, cloud API, I could just use localhost, this URL, I think it's like API generate, to actually integrate Ollama into my local applications. And that's the beauty of it. You can also, that's what I've done. If I go to localhost 3, so this is basically local chat UI. And if I create a new chat, I can just say select a model, and you see this is the same list I just had in my in my console. And if I, for example, take Dolphin Llama 3, you can just say, hey, the classic, write the game snake in Python, and then it goes ahead, loads it, executes it in a ChatGPT-like environment, which you also can set up for your kids. You can set it up for with different users, with just member roles and not admin roles. You can also create model files, which is another nice feature of Orlama, where you take an existing model and you can like modify it to give it some system prompts and categorize it. And when you're done, you just save it, and then you have basically a modified and prepared version of your model to be used in the chats. This is called Open Web UI. Just have a look at it, but I found it really cool to have it like run completely locally with really usable kind of interface. And yeah, it's open source, it's free. Just use it. You can also go deeper and let it generate images or upload documents. You could also put documents in here for vector search. Yeah, a lot of nice stuff. Completely locally, completely without any use of any API. And yeah, as you've seen, I have a pretty strong machine, but still, it's really fast. Okay, let's get back to our app. So we explained Orlama, and now what we need to do is just we have our emails, and we can iterate over our emails. So what would be next? Next would be execute as LLM classifier. So what I like to do, Next.js has some neat features, one of which is you can just create APIs inside your web application. So for that, you just create a server API, like a full API. You create a new file, and we call it like, let's just say prompt, and then we just create route.ts. So this is not an Next.js tutorial, so I won't go into deep what this all means. But basically, what we've done now is we created a post. We created a post endpoint, which we can hand over our email, for example, and maybe let's rename this. Name it classify. So, and yeah, now we can execute it. One thing we will need for our application to work is LangChain. And if I'm not wrong, we have LangChain, Orlama. Yeah. So, I'm on the Python version. I need LangChain.js. So there is a LangChain for your information. LangChain is a library which I use basically to abstract all the different interfaces. So because you have like a really rich library of integrations. You see, you can integrate different LLMs. You can integrate document loaders, document transformers, compressors, embedding models, vector stores, so on and so forth. So you really have a lot of stuff, and there is a Python version and there is a JavaScript version. Please be aware, if you use the JavaScript version and the Python version, they are not the same. They don't have the same namings. They just differ. Mostly the Python version is a bit ahead in terms of functionality, but yeah, that's that. Okay, so LangChain. So we install LangChain into our app. We also need to install LangChain community. should install at least. Oh no, oh, wait a second. I don't have an. So we need to do. Burn add. Nice. That was quick. And let's just see how this works. So we first of all create, like import the Ollama abstraction layer. We create a model. And base URL stays the same because we didn't change it. We just want to take Dolphin Llama 3 as a model. And do we want to stream? I think for the time being we just try to invoke. So yeah, you have different ways to use inference. One thing is just like set a prompt, get back the whole response, and you're good to go. But you have to wait, and to not to wait and to have it like we have it like here. If I send like ping ball, so we don't wait for the whole answer, and it generates the answer on the fly. So it streams the response down and uses basically HTML streams in their standard way to achieve that and to give you back an answer before you went ahead and finish it up. Because this is possible because like LLMs work like generating token by token. So every token it generated can also be put out. So that's why streaming is possible. And that's why also LLMs cannot predict stuff because they make it up on the fly, literally. But yeah, we still can, I think, copy this one. Or just, we do like this. Like const risk await generate prompt. No, invoke. I think invoke. Yeah, invoke. Body. And what I will do now is I don't want an object. I will do text. And in JavaScript you can say text classify the following text into one of the following categories. Yeah, let's do it like this. So we just hand over the body. We will improve on that, and we want to give back res. So okay. So what we now did is we created a post API, and this post API we can just execute and give back the result. So I would love to actually, I think, open Postman. Okay, nice. Let's just test this API as it is. You say Postman, we say HTTP //localhost 3000 because that's where our API is sitting, like our application is sitting, and then we say API and say classify. We don't need any authorization; it's all local, run locally. What we do need is a JSON input where we say I think body was it, right? Here is an invoice for you. So if we now send this, you see, yeah, we get an answer, but said is, I'm sorry, but I cannot classify the given text as it is not any in any of the recognized formats. Please provide me with a valid prompt. Okay. So this is basically a prompting issue, right? So we have classify the following text into one of the following categories. Maybe classify the following text contents to one of the following. Let's do it like this and say body from an email body into one of the following categories. And let's say answer in JSON format with the category as the value category. So, okay. Now we saved it. It's basically on the fly. And if we now try this again, yeah, it gives up like category personal. So still something to work on. It's stating the invoice. So, well, that's like, I think that's an experience that some or a lot of you might be able to relate with, because how often do we prompt an LLM and it actually does not behave as we want to? Like, it's saying invoice. Why does it categorize it into personal? By the way, why do I have breaks here? So that we can solve pretty quickly. So what I like to do usually is to say let res JSON, because this is something that can be a bit tricky, because sometimes LLMs, like, they add something like markdown markdown markers for markdown code blocks. Sometimes they say something, yeah, of course, here's your JSON and that stuff. So to avoid that, you can add something like always start with a opening bracket and always end with a closing bracket. And what I do to be like really safe is like say, hey, just say, let's do this undefined for the moment, for the time being. JSON undefined. Okay, so okay, we try to parse it. If there is anything that's not JSON format, then it will fail. We will catch it, we will write the console error, and we basically say res will be res JSON or res. So that way we see, okay, if this is not undefined, we give it back. If it is undefined, we just give back the text. It's also not completely how you would implement it in production, but for the moment, then you get a proper answer. One thing you already see, of course, we don't use a lot of tokens for the moment, but we have now already a working endpoint on our local system, which we could integrate in our own app, and also in any automation. So if I would love to, for example, use Apple shortcuts, I could create a shortcut which calls this API, and go on with this. So yeah, that's how you would use Olama, and that's the beauty of Olama. It's running locally on your server, and it really yeah, it's really fast, at least with small models. Are they perfect? No, they don't. They aren't. But nonetheless, you have a lot of um, you have a lot of ways to tune and tweak this, and yeah, that's also what we do. Like that's live build, right? Okay, that's that. Let's recap a bit. So we have we went through Olama and all its benefits. We went through LangChain, where we directly checked how to integrate Olama. We went through the Olama model library, showed that you have different models with different like um, complexities. You have we have spoken about our core principles and what we're basically aiming at for yeah for overcome challenges. And by the way, the challenges building AI agents are a lot more deep than that. But as we go along and build stuff out, I'll love to go deeper into that. And yeah, these I think I have to call. Wow, how do you principles? I guess to for AI for evaluation of feasibility. No, yeah. Yeah. Okay, let's leave it with that for now. Let's make it also big. And of course not. Okay. Now this is not okay. Good. So we have emails. This check we skip it for now. We have the classifier endpoint. We have now to see that we connect this to our email. So let's see how we go about that. So our endpoint is created. We could also do something that would go a bit deeper into how Next.js and stuff works. So we'll leave it for now. But usually, what you do, you have an API, you call the API from your front end. In Next.js, things are a bit different. So per default, this is not this is not a usual like client component like you know it from other React applications. This is by default a server component. Means this is pre-rendered and also cached, so that all your loading times are really fast because it's pre-made server side. But how would you go about client side clients and interactions? Like where is the JavaScript? Because this, if you take a look at it, actually came as the whole HTML, and that's also let's see if we reload this. Payload. Yeah, this is basically the HTML which came from the endpoint we just called, which is localhost, of course. So there is just like a minimum amount of JavaScript loaded, and the rest is HTML. So no interactivity here, like no buttons, no nothing. And how would you go about this? So what we will do, we will create a new file, and we say this is our email component. Component.tsx. Always forget the snippets. How do I create a client component? Page component, client component, CRC. CRC. These are snippets. Yeah. So now you see what we have here is like we have a use client, and this use client is kind of interesting because you have now a client component which we can integrate in our server component. And what it does is it allows us to actually create a client component with all the interactivity and like exchange this part. So let me quickly just copy this into here. Maybe we also could do this. So now, of course, it doesn't know email, right? So what we will do here is we create a parameter which is email, and this is email, and yeah, I think we miss one of this. Yes. So this is something that's still bothering me with GitHub Copilot, is that he's not able to properly close off. It's gotten better, but it's still annoying. So as of now, so we have now created the email component. So what we can do now is basically just go ahead, throw this one out, and say email. I think I didn't name it properly. Email component. Okay. So I'll try to keep it short because this has nothing to do with AI. But what we'll have is the following. So now we have our emails. We can see they're rendered out as we're used to. And now what we can do is we can add a button here. I think a button would be fine. Button, classify. Yeah, nice. Thanks. That's why I like Copilot. It's just like it's thinking ahead. So okay, now we have an email component, and this email component gets the email ID and the email. I like the key email, like, because you have to have a key on list items. And now we have a classify button. I think we should maybe change this to be something like, let's go with something red. And let's just say PT is 2 and P. No, not PX. PY and PX is 4. Just for looks. Yeah, this looks better. And what I want to do now is I want to add a function which basically calls classify email, just an async function. So, and for now it would say there's data, but I want to also have const. I want to have the category just for now saved in our component, and say category, and again doesn't close up properly. So we say on click classify email. Okay. So what we do now is we call our own endpoint, we make a post application JSON, we stringify the text email body. Yeah. Then we get back the data, and we don't want, maybe we also console log the data, but we set this, yeah. Look how GitHub Copilot, at least for small projects, it knows the code base and assumes a lot of stuff. So I don't know about you, but it saves a hell of a lot of time for me. So, and now we should be able to classify, and it gave us an error. Why? Let's check our server. What is the issue? Cannot read properties of undefined reading text. So let's see. Body text. I think we did the wrong body. Okay, that's weird. That should work. Is it email body? Yeah, it is. Subject, body. And it gives over the email. This should have worked. Where does the arrow occur? Route 1818. Yeah, yeah. 18, really? No. Interesting. So what is what the issue? It takes body to text. Okay, never mind. Let's just do text. I got this one wrong, sorry. Okay, let's try again. Oh, now it's classifying. Nice. Category newsletter. Okay, nice. This one is category invoice. Okay, this one he got. I think he would have gotten it properly because I think I messed it up in my. No, I said body, and body.text, of course, is undefined, and that's why he wasn't able to do it properly. Interesting. We should have the need for a default or other category, but that's also tricky in and of itself. But yeah, so I think we are already at a good spot here. Don't have any data handling and stuff like that, but for the moment, I think we are able to locally classify, our emails, which is already cool. I think we're a good spot. Nice. I wasn't expecting that to be as works properly as it did. So as it seems for now, like at least the Dolphin version of Llama 3 is seemingly really good at giving back JSON. So that's something that we can definitely take away from here. And what we also can take away from this whole exercise is that we can run LLMs locally with a proper inference time. So yeah, I'm honestly, how long did the request take? So now let's see, we clear this up, and let's just classify this one. So it took 482 milliseconds to classify our email. And yeah, I think that's already pretty satisfying, and it does it at least with the small email bodies now. Does pretty well. What will be the next step? So the next step would be to get this all, like, in some way, shape, or form into where I don't have to click every email by myself, and also at some point get into a background task. And that will be a bit of overkill today. I might do some improvements on that off stream. But what we can do now is actually we are able to we have created an endpoint. We have created some emails and we classified the emails. So we basically are at a good spot. Let's see. So we have a first easy classifier. We classify into invoice. I also have lead, support, and unknown. Okay. And then we have to go about to see how we can actually create more structured data from it. What we have actually different ways to go about this. So if you want your LLM to have different tasks, you have basically different ways to going about that. So you can do like a classical way, where you would just take the classification and run an switch statement. So that would be one way to go about this. Classic. So another way to do this would be a lot more intelligent, and the AI way would be something that's called function calling. The thing is, and that's definitely something to consider, and we will see how far we can get with a function calling method. Let's call it the AI way. So function calling basically means you have a prompt which says, hey, this is your task and this is what you can do. Now execute the function that is appropriate, or that you think is appropriate for the current state of our task. This could be something like, for example, retrieve docs, or search the web, or classify email. Insert into CRM. So stuff like this could be some that could be some function definitions, and you basically say, hey, these are my function definitions, and you have, if we maybe call function calling. So if we look at this in the OpenAI version, might zoom a bit in. So yeah, there we have an example. So they have a function get current weather, and it gets location, it gets a unit. and it says, okay, get the current weather location. If Tokyo in location lower, then yeah, just jump the temperature. So this is basically a mocked version of a weather API. And what it now does is it takes, it creates a message from the user. And this is what we would basically hand over as a current task, or the email body, stuff like that. So that would be the user request. Okay. So, and the user asks, "What's the weather like in San Francisco, Tokyo, Paris?" And what what they do is they define tools which can be used to answer the question. And one of the tools would be a function, and this function has different parameters. It has this name. It has the description for the AI to understand what the function does, and it has parameters which are from type object, which contain a location, a property. This property is string. Also the description, which is important, so that the AI understands what actually happens here, and also a unit, which is an enum, and it can choose between Celsius and Fahrenheit. So I guess it executes it based on the locally used unit. But it also says it only required location. So maybe it just gets you the fills up the unit part only if the user asks for a specific unit. So, and what it does now is they create a chat completion, and given the message and given the tools, and say, hey, the tool choice is outer. So you yourself can choose the tool to use, and you have to imagine like this is an array, and this is just one tool. You can add like 100 tools, but this all will fill up your context because the tool library is getting is being sent every time you execute a prompt. And if you also add in stuff like memory, so your context can add up pretty quickly. So this takes like a bigger chunk of what actually is needed. So, and then it responds, and has something it's called in this that is called tool calls, and then it checks for that and basically executes the tool call calls classically, and hands over the message to the LLM and gets the response. So that's why it's a second response, because it executes the tool, it gets the information from the tool, adds the information to the context, and therefore creates a new message. It says tool call ID, name of the function, and the function response. And then it goes ahead and executes the whole prompt with the information retrieved from the function call. So and that's basically how it uses an external tool. In this in that example, it was get the current weather to answer a question which it does not have any info on as of now. So back to our email concept. So function calling would be one way which I would love to solve this, because what function calling allows you is to let's put this here. What function calling allows you to do is basically create more intelligent solutions. this is kind of okay. So let's just do it like this. What it allows you to do. So what it is, what it allows it to do. So first of all, you can create more interactive bot chat experiences. So for example, if you have a retrieval process. So you have a RAG pipeline. So you have a RAG pipeline, and this RAG pipeline, for example, is a support case. So the user comes in with a request by user, and the model tries to retrieve it. Retrieve documents with the retrieve function. So the next step, it checks document relevance, because maybe our vector search found the wrong document or no document, and it checks. And then it can decide by itself if it executes the function to get more user info, which would basically go ahead and ask for another input by the user, or to rewrite the query based on context and try to search again. So which would make it more of an interactive thing, because it can ask for more information. You can give it a tries to execute the retrieval again, and you don't have to build like 1,000 prompts for this, but you can build like one kind of master, add functions to get more information into your context, and then you get a much more non-linear experience, because otherwise you go ahead, for example, we retrieve a document, we check the document for its feasibility, and then we have another prompt which says, okay, if the documents are empty, or we don't, AI doesn't seem to like them and then says they're not feasible, then we go ahead and take basically the next the next step, which is then in our linear way of doing this, ask the user for more information. And that is not completely intelligent. Like most RAG pipelines, I don't even go that far, because they only do like, hey, this is a request. We try to retrieve a document for the request using an embedding model. And now we have the document, and we can answer the question with the document in the context. That's not really intelligent. It's more the value of the vector database search and the embeddings than it is by the language model. So if you want the language model to really go about reasoning and to really be intelligent in a more classical sense, you have to give it some tools to extend the context. That's also basically a principle we could I would love to add here, is it's all about the context. So which basically means, hey, everything you want to work with is has to be in your prompt, because your context has to contain everything at inference time to be considered, because LLMs in and of itself for the time being are stateless, so they don't have a state. You execute something and it just generates the next token. It doesn't know anything about what's in front of it. It does not plan. It just generates the next token. It's like a token generating machine. I was always saying it's text indexed out, but meanwhile we arrived at multimodality, and we have image in, text out, and image in, image out, and stuff like that. So even create complete audio tracks with with nothing but our prompts. So yeah, that's how I would love to view it. It's like all about the context. You have to give it the proper context for it to make proper use of the tools it is given, and with the tools it can extend its own context, and that's the magic. I think that's where we have to go in and try to really have the thing decide for itself, and then we really are able to have a self-reasoning model. Yeah, I hope that made sense. So yeah, it's all about the context, and if you try to design an AI solution and you already checked the other principles, maybe I even do it like this. So then we say, yeah, okay, I know we have language understanding involved. We have unstructured data that we can make structured, and it actually saves us time or money, or improves our communication, which also could be a value add. Then the next thing you have to check is, for designing application, what do I need in the context besides the system prompt and stuff like that? Like what do I actually need in the context of my inference call to actually be able to answer the question. Like I have spoken to customers or potential customers that were like, okay, we have to put in data, like can't it answer? Like I thought it's like artificial intelligence. I'm like, yeah, you could like hire human intelligence, but he wouldn't be able to answer questions about your system without having any documentation or any training whatsoever. So that's definitely something you have to think of. It's like, how do I get the data I need to answer the queries that I expect? And to be completely sure, for example, you can set up temperature, which basically says, okay, you're not allowed to be any creative whatsoever, and and what I, for example, have done in my retrieval pipelines, mostly for RAG, is like, hey, you have like temperature 0, you don't make up stuff, you don't be creative, you don't try your own way, just try to answer based on the context you have and nothing else. Whilst if you have stuff that's more loose, like write a poem about whatever, a high temperature might be usable. So that's basically what you get if you can use function calling. It's like hand over tools to the LLM to make a more interactive pipeline. I think like it's remove RAG pipelines. It's just say AI pipelines. Okay. So yeah, that's it for today, I guess. I think we're at least able to classify the body of an email. We are like you see, like now he had to load the model, and it took a bit more time. If I specify this again. Yeah, it's back to 400 milliseconds. So you see, like Ollama stays in cache for some time, but then yeah, it goes ahead and yeah, just removes it at some point from the system memory that it has to reload. But with the small models, it's still pretty fast. Okay, let's sum up once again. We were able to build an application. In this application, we had some mock data for email. We handed over the email body to our first AI function call that we implemented, which gave us which used the Dolphin Llama locally on my machine using Ollama, and is, as we've seen, pretty quick. We also learned about Ollama. We also had a mention of LangChain. I will do some separate videos on my channel on YouTube to explain that stuff a bit more. But yeah, for the time being, that's it for today. What will be next? I think next we will go ahead and try to yeah, really implement a more proper, maybe even function calling approach to work through our emails. We will see how we can maybe I'll prepare it off stream to get some emails from actually my email server, or some dummy email server I create and just forward some random emails from my email list to. And yeah, I'm looking forward to have this a bit more ironed out. Maybe create also some background tasks which are just able to process through all of this. Also, for the time being I planned the manual trigger anyway, so an application and then letting the application run would be suitable. Also, you have to think about things like pagination. Do I all the emails at once, or how can I create background tasks for working through all of this? What about stuff like authentication and security if I need to access an email server, for example? So there's a lot of stuff that still needs to be figured out. I'll try to reduce the stream in the future to more of the AI related stuff, like how do we actually work on the prompt? How do we use Ollama? How do we switch models, for example? So that stuff that's necessary for us to get the application running. And of course, this application itself should evolve in some way, shape, or form into a benchmarking application. At least that's what I would love to do. And so that every new model that releases, we can just like select the new model, throw it in the ring, and see how good it does the classification tasks we throw at it. And but that's more of a long-term goal. And yeah, thanks for listening. Let me switch